Now let's take moment at center of column. Clockwise is positive. Delete nyo muna yan. Ayan. So, from the center, ito, which is at h over 2, let's take C sub C. Ang lever arm ni compression concrete from the center of column would be h over 2 minus a over 2. Ito yon. And then, ang CS3 naman, take note na compression concrete tsaka compression steel 3 would give you a counterclockwise direction. Ano? So, positive muna ang ginamit natin dyan. Positive, and this is also positive. Ang lever arm ni CS3 ngayon would be h over 2 minus x3. Ito, okay? And then, CS2, wala kasi it passes through the center of your column. So, CS1 ngayon would be clockwise direction. Ito na ang ating negative. Lever arm niya ay x1. Remember, this is x1 minus h over 2. Yan. So, that is equal to 224.576. Paano nakuha yan? I-divide mo yung equation na yan by 1,000, I think by 1 million para maging kilonewton meter. 1 million kasi newton millimeter yan. Next is eccentricity is equal to nominal moment all over nominal axial load. Okay? Remember that moment is equal to eccentricity times your axial force. So that would be 41.14 millimeter. You multiply nominal moment and nominal axial load by capacity reduction factor phi, which is 0.65, will give you these values. Ito nga yun yung i-plot natin sa interaction curve. Next would be point 4. This time, strain in steel is equal to 0. Ang steel na sinasabi dyan, yung outermost reinforcing steel, which is AS1. Okay? So, yan. 0. Or, your distance, small c, is now equal to the effective depth, D. Okay? Or that is also equal to your x1. In this case, this is 457 minus 40, clear cover, minus 10 na stirrups minus diameter of bar all over 2. So that is 393. Note na D is also equal to x1. Ito, si x1. This is also equal to D. Next, your D prime naman, ito yung centroid nung bar number 3. This is also equal to your x3. Okay? So, centroid, this is equal to clear cover plus stirrups or ties plus diameter of bar all over 2, that is 64. Okay, now, same procedure as in point 3. Ang una nating in-equate is strain 3. Okay, so strain in steel 3 is equal to D minus D prime all over D times 0.003. This equation came from similar triangles. Okay? Yung similar triangle concerning this bigger triangle, which is defined by 0.003, yung strain ng concrete, tsaka yung distance D. Okay? And then, in-equate din natin siya sa smaller triangle defined by strain in steel 3. Ito. All over D minus D prime, or that is x1 minus x3. Okay? So, ito yung ating smaller triangle. Since we know what is D, alam din natin si D prime, magiging 0.0025 ang strain. Next, for the FS3, okay, Fs3 is equal to strain in steel multiplied by elasticity, which is 502.29. Okay? Note that this is greater than Fy, meaning nag-yield na yung steel 3. Hindi pwede nating gamitin ang yield stress. So, dapat Fs3 is equal to 414. Okay? Yan yung Fy. Hindi ka pwedeng lumampas ng Fy. Next. So, gagamitin natin ngayon 414 dito sa Fs3. Strain in steel 3 multiplied by Fs3 minus 0.85 F prime C, this is 721. Remember, this is 414. And then, strain in steel 2, the same principle as in ratio and proportion, ito siya, is equal to 0.0013. And then, you always check. Fs2 is equal to strain multiplied by elasticity. So, 251. It is less than your Fy, kaya okay lang na gamitin natin si 251.145. So, use that here. So, compression in steel 2 is now equal to 280.395. Remember na, you divide this equation by 1,000 para maging kilonewton. And then, finally, we have compression concrete is 3581.42. Yung ating small c is equal to your 393. Next, you add all forces. Bakit add lahat yan? Okay? Remember na CS3 is compression. Compression concrete is also compression. Compression steel 2 is also compression. And yung tension bars mo or AS1 is 0 dahil 0 ang kanyang strain dito. Okay? And take note na yung ating strain diagram, walang negative triangle. Kaya compression lahat sila. Okay? And then, that is now 4,583 kilonewton. You multiply that by 0.65, you get this ppm. Next is your nominal moment. So I will split. Your nominal moment, taking moments at the center of your column, or that is at h over 2. Okay, so unahin natin si compression concrete. Ang lever arm ni compression concrete would be h over 2 minus a over 2. Sometimes you have to check if compression concrete is below your h over 2. Kapag compression concrete is below h over 2, then that becomes now clockwise direction. Samantalang si CS3 is always counterclockwise direction. Okay? So remember that. So, by this figure, compression concrete is above h over 2, kaya positive ang gagamitin natin. And then, si CS3 naman, positive din kasi counterclockwise direction. Si tension, obviously, 0. Si CS2, wala kasi it passes through the centroid of your column. And then you multiply your axial and your moment by 0.65. That will be your plot points. Sa 0.5, walang quadratic equation dito. So, ang assumption natin ngayon dito, yung strain in steel 1, ito, this is at the level of your AS1, is equal to 50% of your yield strain. So, that is 0.5 Fy all over ES. And then, from there, you can compute your small c, or that is the location of your neutral axis. Ito siya, no? So, by ratio and proportion, small c is equal to x1 all over 1 plus strain in steel 1 all over 0.003. And then, always check location of your neutral axis. Ito. So it is below h over 2. You simply check if small c is greater than h over 2, then it is below. Lahat ng forces sa taas ng neutral axis is compression. So that includes your compression concrete, your AS3 and AS2. This time, meron na tayong stress reversal. Or, dalawa na ang triangle mo. So, ibig sabihin, meron ka ng tension force. And then going back here, remember that A is equal to beta C. And then you can now compute compression concrete. And we now go to compression steel 3. First, you have to check your FS3. FS3 is taken from strain in steel 3, which is this equation. And then, you multiply strain in steel 3 by elasticity. That is probably greater than Fy. So, you compare this with your Fy. Lumalampas na mas malaki si FS3, si actual FS3. Kaya, pinili niya yung 414. Next, so, compression in steel 3 is equal to AS3 times 414 minus 0.85 F prime C is equal to this. And then, let's go now to strain in steel 2. This is 0.007. Paano nakuha yan? Palitan mo lang ito na x2. Okay? So this is 0.0007. Next, you multiply strain in steel 2 by elasticity, magiging 130.79. Notice that this is less than your Fy. Kaya, okay lang siya. So, CS2 is equal to same equation here. CS2 is equal to AS2 minus the quantity FS2 minus 0.85 F prime C. Take note na ang ginamit na FS2 is 130.79. Next, we now go to strain in steel 1. Dahil ang kukunin natin ngayon yung T1. Hindi na siya CS1, ano? Tension na siya kasi meron ka ng stress reversal dito. And we know that strain in steel 1 is 0.001. Yan ang gagamitin natin dito. And then, you check strain in steel 1 times ES, that is your actual FS1. Compare that with Fy, okay? Whichever is minimum, yan ang kukunin mo. And you get tension in steel 1, 383.38. Now, let's compute your nominal axial force. This time, meron na siyang tension. Kaya, ang nangyayari dyan, ito. So, actually, yung nominal axial force mo, yan yung sum ng mga forces dito. So, compression concrete plus CS3 plus CS2 plus T1. Note na ito ay opposite direction. So, minus T1. Okay? Ayan siya. Minus TS1. And then, going to nominal moment, let's take moments at the center of your column. Always take moments at the center of columns. So, i-identify muna natin ang forces above the center of column. So, meron tayong compression concrete tsaka compression in steel 3. Si CS2 passes through the center kaya hindi na natin siya isasali. So, we only have 2 compression forces and 1 tension force. But take note na all these 3 forces is causing a counterclockwise direction. Kaya lahat sila plus. Positive ito. Okay, so lever arm of compression concrete is H over 2 minus A over 2. Ang lever arm ni CS3 is always H over 2 minus X3. At ang lever arm naman ni tension steel is simply H over 2. Okay, so you have here 459.35 kilonewton meter. Lagyan nyo na lang ng M dun. Next, you multiply these forces by 0.65 and then you have the plot for point number 5. For point 6, this time, ang gagamitin natin na strain kay AS1 would be your yield strain. Okay, so that is Fy all over ES. Notice na madali nang masolve ngayon si small c or the location of your neutral axis. So from this equation, this is taken from, again, from similar triangles. Ang larger triangle natin, ito, it involves your 0.003, tsaka yung small c, tsaka yung strain in steel 1, which is Fy all over ES, and your x1 minus c. So you can easily solve small c, which is 232.54. And then you can compute now your A, which is beta C. From there, you go straight to compression concrete. Ito na yun. This is the area of your rectangular block. 0.85 F prime C multiplied by A times B. Divided by 1,000 para magiging kilonewton. And then, let us compute strain in steel 3. Notice na malaki ang strain in steel 3. Okay? Compared sa strain in steel 1, which is already at yield point. So, you always check strain in steel 3. Dapat hindi siya lalampas ng 414. Kaya meron tayong minimum dito. Okay? So, compression in steel 3 now is AS3 times the quantity 414 minus 0.85 F prime C divided by 1,000. You get 721 kilonewton. Likewise, sa strain in steel 2, this is again by similar triangles. You multiply this strain by elasticity. Okay? And then you compare that with 414. Okay, so lumalabas na ang actual stress in steel 2 is less than 414, kaya okay lang yan. So, compression in steel 2 now would be AS2 multiplied by 10.43 minus 0.85 F prime C divided by 1,000 would give you 12.85. Next is, dito na tayo sa bars below the neutral axis. So obviously this is tension. Nagkaroon na tayo ngayon ng stress reversal. So, T1 is equal to AS1 times FS1. But, FS1 is equal to Fy. Okay, so nag-yield na siya. Now, we add all forces to get your nominal axial load, which is Pn. Okay. Remember that at point 6, nag-yield yung compression concrete, 0.003. Nag-yield din yung tension steel na strain in steel Y. So this is actually your balance point. Okay, remember that? 0.6 is balance point. Kaya meron tayong PB dito. So that is P balance is equal to Pn is equal to compression forces minus tension force. Next, we now compute the nominal moment. So again, you take moments at the center of column. Ang forces above the center of column, you have compression steel 3, tsaka compression concrete. Yung CS2, it passes through the centroid, kaya hindi natin po-consider yan. And also, T1 will cause a counterclockwise moment. So lahat yan, pare-parehas ang direction. Kaya plus, plus, plus. Okay? So, compression concrete times the lever arm H2 over 2 minus A over 2 plus compression steel 3 times the lever arm H over 2 minus X3 plus T1 times lever arm X3 minus H over 2 divided by 1 million. This becomes now 519 kilonewton meter. Next, you multiply these two forces by 0.65 and you have your balance 0.6. Ito ang iyong i-plot.